So let's take a look at, these are some problems that I've pulled from some old AP exams. And they're all probability questions of some type or another. Some of them are multiple choice, some of them are free response questions, all that kind of good stuff. And we'll go over them together, and I'm going to let you guys sort of guide what we do. So, the number of sweatshirts a vendor sells daily has the following probability distribution. If each sweatshirt sells for $25, what is the expected daily total dollar amount taken in by the vendor for the sale of sweatshirts? So there are two different ways we can approach this. I'll take a suggestion. Yeah.
We do the expected amount equals the 0 times 0.3 plus 1 times 0.2 plus 2 times 0.3. That way.
And then do what?
And then add them all together.
Then multiply by 25.
Oh,
And then multiply by 25.
Oh, okay.
Right? So you can either do that, or the other way that you could do it is you could put the dollar amount up here and go, all right, if I sell zero, I get $0. This would be 25, 50, 75, 100, 125. Either way is fine, but you got to multiply by the 25 sooner or later.
Yeah.
It does not matter. Does anyone have a strong preference?
I like the.
I like this first one.
Oh.
We can do that.
Well, I just like putting the 20, like 25, 50, 75, 100, 125.
So Ariel, you're the tiebreaker here.
The second one.
Okay. So this would be the dollar amount taken in. So 0, 25, 50, 75, 100, 125. This person's not making a lot of money if this is per day. So our mean is going to be 0 times 0.3 plus 25 times 0.2 plus 50 times 0.3 plus 75 times 0.1 plus 100 times 0.08 plus 125 times 0.02. Ooh, I'm going to do this in my head. Or without a calculator at least. So this is going to be 5 plus 15 plus 7.5 plus 8 plus 2.5. So that's 10, 18, and 20. Is it 38?
Right on the dot.
Yes, sir.
It helped that that was one of the answer choices. All right. So, which of the following statements is true for two events, each with a probability greater than 0? I will let you read over those, and then we will discuss. So, y'all talk it over between yourselves. Come up with a consensus.
I said E.
Oh, I
Oh,
Let me see.
mutually exclusive, that means disjoint. So it's saying if events are disjoint, they must be independent.
Oh yeah, and because they can't be independent and disjoint.
Correct.
So then, yeah, because I remember hearing that term mutually exclusive. But
Mutually exclusive and disjoint are the same thing.
right, okay, then I agree. Then it
Do
would
you
be.
agree, Ariel? Awesome.
Yeah, so it's got to be E.
Okay, sweet. So then, how would you describe independent? If mutually exclusive is disjoint, then what would independent be?
Independent means the probability of one of them happening does not change the probability of the other one happening.
Oh, I remember we had this conversation because they're kind of similar, right?
They're kind of similar, but they're not. Disjoint means that if one happens, the other one cannot happen.
Oh yeah, but independent is just they don't affect
The
each other.
probability that someone who's a first class passenger dies, it doesn't.
Affect.
Yeah,
Okay.
the fact that they're a first class passenger isn't affected.
Okay, that makes sense.
All right, in a carnival game, a person can win a prize by guessing which of 5 identical boxes contains the prize. After each guess, if the prize has been won, a new prize is randomly placed in one of 5 boxes. If the prize has not been won, then the prize is again randomly placed in one of the 5 boxes. If a person makes 4 guesses, what is the probability that the person wins exactly 2 times?
Oh, okay.
So I'll pass these out. It's not going to help you. At least not on this one. What is it?
E?
Yeah, it's E.
And how do we know, just off reading the equation, that we'd have to use that little formula? Just
Okay,
the
what
exact-
did you say that it was?
I didn't know. I was gonna do the thing where we usually do, where it's like the probability that you didn't do it, however many times how many you did actually pick it. But
All right, so that's D.
right.
But you haven't taken into account that there's more than one way to get 2 wins. It could be the first and the second, it could be the first and the third, it could be the first and the fourth, it could be the second and the third, it could be the second and the fourth, it could be the third and the fourth. There's lots of different ways. So what this does, this is combinations. 4 choose 2.
Okay, so those are the combinations that.
Yeah, that tells you how many combinations we have.
So, how do you know, like, it's 0.2 and 0.8? Like, where they have that? It's like a 20%.
Okay, how many boxes are there?
5? Oh. That makes sense.
Right? 1/5 is 0.2,
Yes.
which is also how much your semester average goes down for every point you get below your current semester average on the final.
We lose 0.2 points.
So if you had a 90 average and you make an 89, your grade goes down 0.2 points.
Oh, so then I pretty much stay at 90.
Well, provided that it was actually a 90 and not an 89.5. Because if it's an 89.5, now you've gone down half a point times 0.2, Now it's an 89.4 and you're totally screwed.
Yeah. So you say it's not D again, just to make sure, because there's multiple ways to get the same outcome and they give us that out? Okay.
Yep. All right. Let's move on.
So Mr. Davis, just real quick. So
Yeah.
whenever it on the ones where it says we won on, say, out of 5 trials, we won on the 5th trial. That's the one where we don't need the 4 choose 2. We could have just done.
If the first time you won was on the first trial, that means you have didn't win, won.
Right. Okay. That's what I was thinking.
There's only one combination.
Right. Okay. Because they
Right.
tell you when you won.
Yeah.
But this one, there's a bunch of different combinations. That's what we have to use.
Yeah. If you wanted to win just once, you would have to do 4 choose 1 or whatever.
Mm-hmm.
Does that make sense?
Yes, sir. I think so.
So the way Birdie's talking about, that's
I'm sorry.
the way Birdie's talking about, that's geometric, right?
I'm sorry. Say it again slower. I keep hearing something about birdies, and I'm like, what are you talking about?
No, I'm saying the way that Brody is talking about, that's geometric, right? Or is that still binomial?
So that's just basic probability rules.
Oh, okay.
All right, so here, an urn contains exactly 3 balls numbered 1, 2, and 3 respectively. Random samples of 2 balls are drawn from the urn with replacement. Important idea that it's with replacement. The average, x bar, which is x1 plus x2 over 2, where x1 and x2 are the numbers on the selected balls, is recorded after each drawing. Which of the following describes the sampling distribution of x bar? Okay. So if you've got 1, 2, and 3 respectively, right? Well, how many ways are there to get an average of 1? This should take less than 2 seconds for you to answer. Pardon?
One combination.
There's just one, a 1 and a 1. Right? Then how many different ways are there? So I know that the numerator of this first one has to be 1. So this is gone. Because it says the probability is 0. Right? But all the rest of them, the numerator was 1. All right, so how many different ways could you get 1 1/2?
1. Wait.
1, then 2, 2, then 1. There's 2 different ways you could get that. Right? So the probability for the next one needs to be 2 over something. Well, that immediately lets this out because this says the probabilities are all the same. And this one says the probability of the first 2 are the same, and that's not true. So 1 out of something, 2 out of something. Let's see if this continues to hold. How many different ways can you get 2?
2 ways.
2 ways.
2 and 2 and then 2.
Nope.
3.
Yeah, because 1 and 3, 3 and 1, and 2 and 2.
Yep. 1 then 3, 3 then 1, 2 then 2. And then how many ways can you get to 2 1/2?
2 ways.
2 ways. 2 then 3, 3 then 2. And then to get 3, the only way to get that is get a 3 and then get a 3. And you're like, well, shouldn't this be 3 over something? Well, it was. What was it 3 out of?
9.
3 out of 9, which is 1/3.
Wait, why is it 3 out of 9? Mr. Davis?
There were 3 ways to make this, and we've come up with 1, 2, 3, 4, 5, 6, 7, 8, 9 different things that could happen. I'm just adding all the numerators. 1 plus 2 is 3, plus 3 is 6, plus 2 is 8, plus 1 is 9.
So then, why would like, how do we know the top probability of the numerator would be the amount of probabilities? If that makes sense.
Because the sum of the probabilities must add up to 1. So if you add all the numerators before you simplify any fractions, that's got to be your denominator.
Oh, okay, yes, that makes sense.
It's the only way where you're going to get 1 for the sum of the probabilities.
Yeah.
Okay? All right. Oh, that's from 2002. From 2012. A complex electronic device contains 3 components, A, B, and C. The probabilities of failure for each component in any one year are 0.1, 0.01, 0.03, and 0.04 respectively. If any one component fails, the device will fail. If the components fail independently of one another, what is the probability that the device will not fail in any one year?
Savannah.
Pardon?
Yeah, I think Savannah's at the door.
Hi, Savannah.
Hi,
How are you?
I'm good. How are you?
I'm good.
Thank you.
Hey, man.
So we're on the problem that's labeled 16. It's not the 16th problem,
Oh,
but
okay.
so we're looking for the probability that it won't fail. What is that going to be?
Is it 1 minus the probability of 0.01 plus 0.03 plus 0.04?
No. One of the problems with what you did is you assumed that only one of them was going to fail. What if 2 of them failed? What if all 3 of them failed? If we want the device to not fail, we want A to not fail, and B to not fail, and C to not fail. So we want 0.09 times 0.97 times 0.96.
Would it be 0.99?
Yes, sorry, not 0.09. I don't know what that is.
0.922.
So that's D.
So because it's asking for the probability that it won't fail, we just multiply all the probabilities that they won't fail together.
Because we don't want any of them to fail.
Yeah, it's so simple when you just put it out like that. Just the problem. Make it confusing.
It can.
Wait, when I did it, I still get the same answer.
I'm sorry,
When I did it the way I did it, I still get the same answer.
what did you do?
1 minus 0.01 plus 0.03 plus 0.04. I got 0.92.
You didn't get 0.922, did you? You didn't get the same answer. So that's one of those ones where you kind of luck into the correct answer because it's the one that's closest.
So that's what May was trying to do.
Yeah.
Yeah, which is not what you should do at all.
So then how is it not right though? Because you're doing like the opposite.
But you're doing 1 minus the chance that any one of them will fail. But there's also chances that
Oh,
2 of them will fail. And there's 3 different ways that can happen. 1 and 2, 1 and 3, 2 and 3.
so that one's only just one failing, right?
I'm sorry?
That one that I did is just one failing. Right?
Correct.
Okay.
And then there's also the chance that all 3 of them could fail.
Yeah.
We're looking for the probability that the device won't fail in 1 year.
Yep.
So the 1 year really doesn't have anything to do with it. We're just looking for a device.
Well, all of it was in 1 year.
Oh,
It says in any 1 year.
okay.
All right. So let's take a look at this. A nonprofit organization plans to hold a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all the tickets are sold, one ticket will be selected at random and its owner will receive $50. What is the expected value for the net gain? Oh, it says the expected value for the net gain for each ticket is negative 0.95. What is the meaning of the expected value in this context? So they could have made you calculate that, but instead they're like, we want to see if they understand what that means.
The ticket owners, as in each person buying a ticket?
Yeah,
Oh,
that's how you come to own it, is by buying it.
is it B?
It absolutely is B.
Are you supposed to be answering out loud?
Sure. But I'm giving people a chance to work. Yeah, the expected value is the same thing as the average value. Right? That's how much they're going to lose on average. All right, let's move on. A local company is interested in supporting environmentally friendly initiatives, such as carpooling amongst employees. If it was in Britain, they would have said amongst employees. The company surveyed all of the 200 employees at the downtown offices. Employees responded as to whether or not they own a car and to the location of the home where they live. The results are shown in the table below. So you could live in downtown, you could live somewhere else in the city, or you could live outside the city. Those are all the different possibilities. And you could own a car or not own a car for each one of those. Which of the following statements about a randomly chosen person from these 200 employees is true? So you're going to have to go through them one at a time. Let's do this one together. If a person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area of the city. So, of the people who own a car, so we're only looking at this row. He or she is more likely to live elsewhere in the city than to live in the downtown area. Is that true or false?
True.
That's true. And you're like, well, okay, I don't trust that. I always look at all of them.
Yeah.
So if a person does not own a car, he or she is more likely to live outside the city than to live in the city.
That's false. Yeah.
So, yeah, if they don't own one, only 25 of those 140 live outside the city, so that's not right. The person is more likely to own a car if he or she lives in the city, downtown or elsewhere.
false.
That's pretty obviously false. Most of them don't own in either of those cases. The person is more likely to live in the downtown area in the city than elsewhere in the city.
That's false.
Because they're the same.
Yeah, because they're the same.
Oh,
Yeah. Downtown,
yeah. Oh, yeah.
elsewhere in the city, that's the same probability. And the person is more likely to own a car than to not own a car.
False.
That's clearly false.
Yeah.
So it was A. All right, the commuting time for a student to travel from home to a college campus is normally distributed with a mean of 30 minutes and a standard deviation of 5 minutes. If the student leaves home at 8:25, what is the probability that the student will arrive at the college campus later than 9 a.m.? Everyone should be grabbing their calculators at this point because it told you it was a normal distribution.
So then we gotta go to like the model and everything? Or,
The model and
Yeah, you know, we
everything.
got the model? Or,
Yeah, the distribution.
Yeah.
That's even what they call it.
How do you change the?
Back up.
It goes down. Oh, here.
Oh no. No.
What?
Well, you have to put in the probability of success. Isn't that what we're finding?
What
Am I doing the wrong thing?
We're doing a normal. You're not in a normal if it's asking you for the probability of success.
Oh, I was in binomial.
Yeah.
Okay.
It goes to whatever the last thing you did,
Yeah.
so you have to back up.
We're doing something wrong in it. I'm on the normal model, but I don't think I'm putting in the.
What is the probability that
Times,
will
right?
arrive later?
Well, if you're on the wrong model, then
I'm on the right model. I'm on the normal model.
What the?
And I put in the mean and standard deviation, but I
okay.
don't know how I'm supposed to use the 9 a.m. at 8:25 in here.
Is it?
So we have a normal model, right?
Right.
Where the mean is 30 and the standard deviation is 5. By the way, on the AP exam, if this is part of a free response question, this is how you would show that.
Okay.
This is how you show work. So this is 30. All right. If they leave at 7:25, how long does the trip have to take them for them to arrive after 9?
35 minutes.
35 minutes. Or more, right?
Yeah.
So this is what we're looking for.
0.16.
Yeah. There's a 16% chance
So when we use binomial again,
when it's binomial.
it'll tell you.
No.
Oh shoot. Okay.
Binomial is when we have a Bernoulli trial
Oh.
where you either have a success or a failure,
Yeah.
all that other kind of good stuff. And in a binomial, we know how many trials we have, as opposed to a geometric, which is where we're looking for when is the first one, when is the first success.
This is geometric. No, this isn't geometric.
This is normal.
No. Okay.
It's neither,
Because it's not binomial.
right?
It's not Bernoulli.
It's not a Bernoulli trial.
Okay.
All right, let's see. 33. A mathematics competition uses the following scoring procedure to discourage students from guessing. Then they explain what guessing means, choosing an answer, randomly on the multiple choice questions. For each correct response, the score is 7. For each question left unanswered, the score is 2. For each incorrect response, the score is 0. If there are 5 choices for each question, what is the minimum number of choices that the student must eliminate before it is advantageous to guess among the rest?
What?
I know, I just said one in here. Not really.
Recurrent first of all.
So let's say that you don't eliminate any answer choices, right? So your probability of getting a 7, if you don't eliminate any, would be what?
One out of 7?
Oh,
One out of
There's,
five.
there's 5 choices.
Oh.
It says 5
Yeah,
answer
that's
choices. So the number of points that you would expected
The
For-
number of points or the number of.
so the number of points you would get from that would be 7/5, right?
Yeah, so you get 7 out of 5.
Yeah.
Yes.
Right?
How'd you get this? 7 over 5?
7 times 1/5. You get 7 points and you have 1/5 of a chance of getting that.
So that's if you get one choice correct, or that's if you get.
You guys are way overcomplicating this. It's one question, 5 choices.
Yeah.
Oh, okay.
The probability that you get 7 points is 1/5. So the number of points is 7/5. I don't know. I'm getting some blank stares here.
I
I
get,
was
I get
thinking
that.
there were 5 questions, so I was confused, but I get it now.
It's one question,
Okay.
5 answer choices. Okay, if you pick A,
You have a 1/5 chance of getting it correct.
you have a 1 in 5 chance of getting it right, and if you do, you get 7/5 of a point.
Oh.
You get 7 points. So you're picking randomly, it's 7/5 of a point. All right, what's the probability of getting it wrong?
7 times 4/5. No? But you have.
If you get it wrong,
You get 0. Or no, you get 2.
it's 4/5. But you don't get 7 points if you get it wrong.
Yeah, you get.
You're going to get 0 points. Okay, so when we add those, that's 7/5 of a point. That's less than the 2 points you would get if you just left it blank. If you eliminate one of the choices as being definitely wrong, then the probability of getting a 7 is going to be a what?
7 times 1/4? 7
Well, it's going to be the probability is 1/4.
Yeah.
So we would do 7/4 plus 0 times
Oh.
the 3/4, right?
So we do this until the. Okay, I get it now.
But 7/4 is still less than 2. If we eliminate 3 chances, the probability that we get a 7, excuse me, if we eliminate 2, there's still 3, right? We have a 1 in 3 shot. So that's going to be 7/3, plus if we answer it wrong, that's going to be 0 times 2/3. And 7/3 is bigger than 2. So we need to eliminate 2 or more answer choices as being definitely wrong.
So why are you doing it greater than 2? Or greater than or
Because if you don't put anything, you get 2 points. So the question asks, how many choices do you have to eliminate before it becomes advantageous? Well, it's advantageous to guess if your expected number of points is
More than the 2.
better than the 2.
Yeah. And then why would you multiply by, or why would you add the 0 times?
It does. Because what if you got 1 point for every one you got wrong? Then that would change things.
Yeah. But you're not getting a point.
Right.
Okay.
That's why I included it in the calculation, because it's possible we could get 1
Yes.
for all the wrong answers, which is kind of weird, but
Yeah. So then I just want to make sure. So you did 1/4 or like 1/3. Like I understood that. Then where is the 7 coming from? Like why
you
would
get
the
7 points if you get it right.
7 points you get it right?
I think you should use.
So the probability of getting one right if you have all 5 answer choices is 1/5.
Yeah.
So your expected number of points, if you just guess, is 7/5,
Oh, okay, that makes sense.
right? And if you have 4 answer choices, the expected number of points is 7/4. And if you just have 3 answer choices, the expected expected number of points is 7/3,
Yeah.
which is now bigger than 2. So it's advantageous if you can eliminate 2. On the AP exam, and actually on the SAT, it used to be this way. There were 5 answer choices. You got a point for every one you got right, and minus 1/5 of a point for every one that you got answered wrong, and nothing if you left them alone. Which meant all you had to do was eliminate 1 answer choice as being definitely wrong, and then it's theoretically to your advantage to guess from among the remaining 4.
No, don't do that.
I think you should use this method on our tests. Where if we leave it blank, we still get 2.
All right, moving on. The probability that a new microwave oven will stop working in less than 2 years is 0.05. The probability that a new microwave oven is damaged during delivery and stops working in less than 2 years is 0.04. The probability that a new microwave oven is damaged during delivery is 0.1. Given that a new microwave oven is damaged during delivery, what's the probability that it stops working in less than 2 years? And you're like, oh my goodness. There's a lot going on there, isn't there?
Quite a bit.
All right. So we want the probability that it stops given that it's damaged. You could make a table for this, but you're supposed to know the formula for this.
So it's P's both of them together over the possibility that it's damaged.
Right. So this is going to be the probability that it stops working and it's damaged divided by the probability that it's damaged. So the probability that it stops working and is damaged is 0.04. The probability that it's damaged is 0.1. So what's the probability?
0.4.
Yeah, I got 4.
0.04 divided by 0.1?
I put 0.01 in my calculator.
Oh, gotcha. Okay, and again, you could make a table for it. All right, the probability of winning a certain game is 0.5. All right. If at least 70% of the games in a series of N games are won, the player wins a prize. Okay, so you got to win 70% of the time. If the possible choices are for N, which is the number of times you're going to play the game, is 10, 20, or 100, which value of N should the player choose in order to maximize the probability of winning a prize? There are no calculations to be done on this.
It's all the same.
Nope.
Never mind.
100?
Nope.
Ah, shucks.
All right, let's think about the rule of large numbers, which says that the more times you do it, the closer your probability will come to the theoretical probability, right?
Mm-hmm.
So if we do this 100 times, we should be pretty close to 0.5.
Yes.
But we want to win 70% of the time.
So 10.
So we want to only do it 10 times.
It's the opposite.
Yeah. It's an interesting way to get you to think about the rule of large numbers. Think about it this way. If you, you would need to win 7 times out of 10. And you're like, well, okay, think about this as flipping a coin. If you flipped 7 heads out of 10, you wouldn't think anything of it. If you flipped 70 out of 100, you're like, something's not right.
Yeah.
The more you do, the closer it should come to the theoretical probability.
And so, wait, so then I was just thinking, if you want more, then you're gonna get closer to 50%.
You don't want to be close to 50%. You want 70%.
Yes. And so why would it not be 20 then? Because that's also a pretty low number compared to 100.
Which one's better? Lower is better,
Yeah, that makes sense.
right? All right. This is a part of a free response question. A charity fundraiser has a spin the pointer game that uses a spinner like the one illustrated in the figure below. A donation of $2 is required to play the game. For each $2 donation, a player spins the pointer once and receives the amount of money indicated in the sector where the pointer lands on the wheel. The spinner has an equal probability of landing in each of the 10 sectors. Okay. Let X represent the probability, let X represent the net contribution to the charity when one person plays the game once. Complete the table below for the probability distribution of X. Okay. So the probability that you're going to end up donating $2 is going to be if you spin what on this wheel? Once.
Every
Oh,
time.
you get a 4? Or you get a 4?
No, your net contribution.
Oh.
It'd be 4, but there's no 4 in there.
Where are you getting 4 from?
Because if you lose $2, but then you gain.
You're asking about the contribution to the charity.
Oh.
So $0.
So that's how much you'd make, because then you're contributing.
No, there's the charity. It's not the person who's spinning.
I know, but then you're giving $2 to the charity.
You gave them $2. You win nothing. You've given them $2.
So it's 6 tenths.
So, yeah,
Oh no, 6.
et cetera, et cetera.
Here are my 2 homeworks
Okie dokie.
from Friday and today.
And then we can use that to find the expected value.